We'll proceed in vector summation and integral calculus. Okay, this is a very broad topic that how we can divide problem into n different parts and then sum part to part and then finally use integral calculus to have the final summation where n tends to infinity. Okay, where n tends to infinity. Like I have really have so many coins in my hand. Okay, the magic of dividing, I believe I have talked about it prior also. The magic of dividing problem into n different parts. I have so many coins in my hand. So many coins in my hand. So many coins in my hand. If I say, if I say that if I throw this coin, if I throw this coin, okay, I have three, six, and nine coins in my hand. It can be head or it can be tail. It can be head, it can be tail if I throw nine coins on the ground. If I ask what is the expected value, what is the expected value of number of head I can on an average, how many heads I can see? If I toss n nine coins, n number of coins, and throw it, then there will be n number of head or tail. How I can say, means can I estimate how many heads would appear, provided if I toss one coin, if I toss one coin, then if I toss one coin, getting head or tail probability is 1 by 2. It may not be 1 by 2 also. Sometimes getting head, it is a biased coin. Getting head or tail probability can be P and 1 minus P, where P is the probability of getting head and getting tail is 1 minus P. P can be anything, 1 by 2 in a fair coin. Otherwise, it can be different in other kind of coin. Okay. Now, in that situation, how we can assess what is the average number of head I would get? Average number of head I would get. Okay, to get average number of head, if I say what is the probability of getting no head? Okay, there is something called random variable. I believe it will be difficult to understand in this context. Consider that what is the probability of getting zero head? Means everything will be tail. Okay, there is something called binomial distribution. Binomial distribution says that how many coins you have, n. So n, c, 0. N, c, how much you want? I want 0 head. N, c, c is for combination. So n, c, 0 will be factorial of 9 by factorial of 0 factorial of 9, 1. N, c, 0. P to the power, how many heads you want? 0. P to the power 0 into 1 minus p. How many tail you want? That is 1 minus p. 9. That will be the probability of getting 0 number of head. Getting a x number of head is ncx, where n is number of coin. ncx. Makes sense? If I say I want to get probability of 3 heads out of 9 coins, 9c3, p to the power 3, 1 minus p, that is q, that is the probability of getting tail, 1 minus p to the power n minus x, that will come as 6. More or less, if p and q are same, then p multiplied by what to the power whatsoever, 1 minus p to the power whatsoever, if I do, it will become p to the power n only. Means p to the power n, 1 by 2 to the power 1 by 2 to the power 1 by 2 to the power up 9, something like that. Okay, now what is the expected value? Expected value means how much I am trying for head 0, for head 1, for head 2, head 3. What is the probability of head 0? Probability of head 0 is head, how many head I want, that is more or less it will come like x into fx. That is called expected value. X into fx, summation for all x, or I would say x. Understandable, right? If I say I want 0 head, then x is 0 multiplied by what is the probability of getting head. I want I want the total count of one head, then one into probability of head. It is similar to if I'm trying to measure the height of a student in a class. I want to measure height of average height of the student in a class. Then what is the fundamental of counting average height of the student in a class? What is the fundamental of counting average height of the student in the class? Then student by student, I'll check the height and I'll measure it on a notebook. Then I'll add it and divide by number of a student. That is the one fundamental. Other fundamental is take x-axis. Take this as x-axis and this is y-axis. This x-axis is the height and this, I'm sorry, this x-axis is the height, and against each height, how many students are there? Okay, for simplicity, I would not take in point, like if height is 5 feet 1 inches point something like that, I'll calculate 5 feet 1 inch 1. If it is 5 feet 4.5 inches, then I'll calculate as 5 feet 4 inches only, something like that. Or if it is 4.5, then it will be 4. The height is 5 feet 4.6 inches. Then it will come as 5 feet 5 inches. This side, that side. But it won't be in fraction or something like that. Okay, now in that fashion, I have students, consider students' height are starting with the 5 feet 4 inches, something like that. Then I have 5 feet 4 inch, 5 feet 5 inch, 5 feet 6 inch, 5 feet 7 inch. Like that, 6 feet is the maximum height. 6 feet 2 inches. I don't think more than that. Now against 5 feet 4 inches, how many students are there? If a student in the class are n number of students there in the class, then against 5.4 inches, consider I have 20 students. Then the height will be 20 by n, that is called probability. So 20 by n multiplied by 5.4, that will be the weightage of 5.4. 5, what is the weightage of 5.4? 5.4 into 20 by n. Similarly, if I take all the height and multiply by the probability, number of students by n, and then if I add all, I get the average number. No. What you have to do is, you take 5.4 and see number of students, not by n or whatsoever. Because I don't understand what is you are saying n. Against 5.4 inches, I have 20 students. So 20 students into 5.4 means 5.4 plus 5.4 plus 5.4, 20 times. Anyway, I would have written in the notebook as 20 times only. So 5.4 student 20 times plus 5.5 student so many times. Like that, if I 5.4 into 20 plus 5.5 into 5.6 into, if I do all the into and do plus, then I'll get the net height of the class divided by n number of students. Then I get the average height. It is same thing. Now, rather than divide by n, you can divide by n here one against each height. That is called probability point mass function. Okay. Now, this is similarly, if I'm trying to get the what is the probability, what is the total what is the how many heads is the average I am getting? If I drop if I drop okay, if I drop 9 coins, if I drop 9 coins, then what is the expectation? How many head I'll get on average? Then it arises in getting 0 head. What is the probability? Now let's draw the diagram. This is 0 head, 1 head or 0 head, 1 head, 2 head, 3 head, 4 head, 9 head. 0 head, 1 head, 2 head, 3 head, 4 head, 9 head. Against 0 head, what is the probability? Against 1 head, what is the probability? Against 2 head, what is the probability? If I add all means 0 into what is the probability? 1 into what is the probability? 2 heads, what is the probability? 3 heads, what is the probability? If I multiply each and then add finally, I'll get the number of average head. Okay, then against 0, then I have to say summation I equal to 0 to n number of coins. Xi, where x is how many heads are there. NCXI, p to the power xi 1 minus p to the power n minus xi, where n is number of coin and x is how many heads we are trying. So I have to calculate for every head is 0, then 0 multiplied by its probability, that is ncx p to the power x 1 minus p. It is very easy to understand. So every multiplication I have to take x into px, x into px, x into px, x into px, and then finally sum it. You get the average. But how many people have caliber? Instead of 9 coin, I have 90 coins. Then tell me what will be the average. Someone will say half will be the average. Means, or consider P is not 1 by 2, then P is 1 by 3. Getting head probability for one coin is 1 by 3. For every separate coin, getting head probability is different. Then, what do you mean by separate coin? You understand? Okay, then it will be very difficult. But consider for every coin I have P and Q. Getting head is P and getting tail is Q. Where Q is 1 minus P and P is not 0.5, 1 by 2. Then okay, now it will be impossible for anyone to calculate 90 times on page and paper. That is I equal to 0 to 90, and then xi, nc, xi, that is the probability part. One is the for which we trying to find the average. That is the random number, it is also called. That is number of head, xi. And then probability of xi, that is nc, xi, p to the power xi, 1 minus p to the power n minus xi. Probably no one would have demonstrated like this in the book. Okay, now if someone calculate for 90 coins, he will start sweating, 100% sure. Dividing problem into n different part. What we are seeing is that every coin, head and tail, if I toss it, then its average value is not dependent upon another coin. All are independent and all are identical. In that fashion, let's calculate the average for one coin and then add for n times. What is average for one coin? Average for one coin is coin can have 0 head or 1 head. So let's start. Summation I equal to 0 to 1, and then xi, nc, xi, and then p to the power xi 1 minus p to the power n minus xi. If it is 0, then full will become 0 because xi is 0. If it is 1 head, then it is 1 into, okay, n means how, I believe it is how many coins are there, that is n. Okay, so n is 1. Only one coin is there. 1c1 will be 1 p to the power 1 minus p to the power n minus n is 1 minus 1 0 gone. Only p will remain. So the average head that a coin can show is p, and all are identical. So I have to add it, n into p. N into p is an average head I can imagine. If p is 1 by 2, getting probability 1 by 2, and there are n coins, then n into p is 4.5. That is exactly half. Okay, can someone imagine it? Then someone say, okay, how many coin you have? I have 90 coin. Then n into p, 90 into p, 45 is your average. Getting head, how many heads you will get? If you throw 90 coins, then it is 45. If p, getting head probability is 1 by 2. Amazing, mind blowing. This is distributing problem into n different parts. Solve part by part and then have the result. Can anyone believe this? How drastically it becomes simple? Provided all the coin result, what outcome we are getting, it is independent to another coin. If I say that if I'm on this coin, if I'm getting head, then getting head on this coin, little bit it dependent upon this coin, then you cannot do. Dividing into n part, you cannot do. All should be discontinuous continuous to other, mutually exclusive. Then only we can divide problem into n different parts. We will use vector and so many things. Anyway, now we have another very nice problem, and problem is there are two ways. A bank is giving interest, or bank is giving loan up to a person what we want. A bank is giving interest on y0 amount that is deposited to the bank with the formula y t1 equal to y, that is the amount at any time, y, and in bracket t+1. T is the year, any t year plus 1, if I am trying to calculate the value, if I have deposited my money in the bank account in a fixed deposit, there is a fixed deposit in bank, and in bank I have deposited some amount, and I'm trying to find out that at the end of 6 year, what is the amount. Bank has given me one formula. What is the formula? Y, and in bracket t plus 1 equal to a into y bracket t. Y is a function over t. Y bracket t plus 1. Y at the time t plus 1 equal to a, any factor a, into y as a function of t. Means if t is 4, then at the end of 5 years, t plus 1 is 5. I believe it is alright. Y, and then in bracket write a small t plus 1 bracket close. Makes sense? Y, the amount at the end of t plus 1 year, if t is 4, then at the end of 5 years equal to a. A is some fixed quantity multiplied by y, and in bracket t. At the end of 4 years, whatever the y was, if I multiply with the a, then that will become y at the end of 4 plus 1, that is 5 years. What is the amount at the end of 1 year? Then it is a. 1 year means y t plus 1, where t is 0, equal to a y 0. What is the amount at the beginning is y 0 into a. A is called growth factor. Growth factor. A into y 0. That is the amount. What is a? A is 1 plus. A is 1 plus interest rate. What is interest rate? Consider interest is 5%. Means if someone is depositing $100, it will become $105 after 1 year. Okay, then after 1 year means y t plus 1, where t is 0, means y1 equal to, after 1 year, y equal to a. A is 1 plus interest rate, that is 5 by 100, 0.05. 1.05 into y, where t is 0, y at the 0th year, that is initial amount. So if someone has deposited $100 would become 100 into 1.05. Pardon me, it can be 100 rupees also, just for symbol. It can be 100 yuan, 100 ruble, 100 franc, Swiss franc, or 100 euro, or 100 kind of Nigerian currency, or 100 pound, whatsoever. Someone feels easy with. It can be 100 taka also. Taka is a very famous currency in Bangladesh. Still in India, people talk in taka only. Okay, I have personally seen many people in India, though it is written as rupee, but they talk in taka only. This is 100 taka, this is 10 taka, this is 5 taka, this is 1 taka. Okay, and then the coin also, people talk in ana only. When I was child, I had never heard this is 50 paise. This is 8 ana, 8 ana, 8 ana, 4 ana, like that. 1 rupee 16 ana, something like that. And then 2 taka, 5 taka, 10 taka, something like that. So people in India, they still follow Bangladeshi way, though it is written as rupee or something like that. So Bangladeshi taka is also very famous. So anyone consider whatever is conducive to him, whatever is near to him, near to his heart. Okay. Okay, so this is how it is. So if I'm trying to calculate what is the principal amount after 2 years, then y in bracket t plus 1, t is 1. So y at the end of 2 years is a. A at the a into y into t, t is 1. Y at the end of 1 year. If I break y at the end of 1 year, so this has to be understood very nicely. Y t plus 1 equal to a yt. What is the y at the end of 2 years? That small t equal to 1. Y in bracket 2 year. After 2 year, what is y? Equal to a y at the end of 1 year, t equal to 1. Then what is end of yt? Y at the end of 1 year. There, let's make a bracket now. Yt will break as yt, where t is 1. Then it will break as y t plus 1 where t is 0. So yt plus 1. So yt, y1 equal to a into y0. So I can rewrite it as y2 equal to a into y0. That is a to the power 2 into y0. At the end of t years, how much amount I can expect in my bank? Then y equal to at the end of t years is a to the power t into y0. Whatever I had deposited y0 0, that will become multiplied by a to the power t. Makes sense? Now, one person is very, very smart. He has taken some other kind of scheme. Okay, what is other kind of scheme is, now one person who is very smart, what he is thinking is, why I am keeping money in the home? There is no need of keeping money in the home. Why I am keeping money in the home? Let's put in a fixed deposit. Why he is searching bank to bank. Okay, I want to deposit money in fixed deposit rather than keeping money in the saving account. Consider consider that I have some $10,000 in my hand. If I go and keep in a saving bank account, then it will give very nominal interest, 1%, 2%, 3% only. Whereas if I keep in saving in fixed deposit account, it may give up to 8% also. Okay, person is very clever. Now he's running bank to bank and he's asking, do you provide a facility like if I keep my money in fixed deposit account, then can I withdraw some $100 every year from the fixed deposit? This is what his need is. Somehow he has $10,000 in his hand, and every year he need to, or every month whatsoever, he need to withdraw some money. That's why he has kept in current bank. So one bank is saying yes, it's possible. You can deposit money in your account and some amount you can withdraw every year. Consider that is the S amount, not a varying amount, a fixed amount he is withdrawing every year. Now he is so smart because he knows that whatever the amount he has deposited in the bank, that is growing at the rate of 8%, whereas the saving bank account was giving him 2% only. It is growing as 8%, and whatever he need to withdraw every year or every month, he is withdrawing. Consider he need to withdraw $100 every month. So every year he will withdraw $1,200 from the amount. But that whatever is growing at 8%. Or or a person needs to deposit some money after depositing the first amount also. Consider someone is depositing $100 for simplicity. Or if someone is going with $10,000, it's also all right. Consider someone is depositing $100 in the account at the beginning in the fixed deposit, and once the 1 year is over, just before the 1 year is over, then that person is depositing $10 in the account. Next year, when next 2 year is about to be finished, he is depositing $10 again in the account. Now tell me how much it will be. If he had not deposited $10, $10, $10 in his account, that any time yt, at any time y, would be a to the power t into y0. The t is in years. How many years he has deposited? That is a. If he deposited at 5% interest, then 1.05 into power t. That is the number of year into y0. How much $100 he has deposited at the beginning. That will be the amount at any time after any number of years. Okay. Now he is depositing S amount in the account every year. That is $10 every year. Every year. Now tell me, after any time, year t, any year t, after 4 years, 5 years, 6 years, any t, what will be amount in the account? There are many sources now. Many sources. One source is y0 that he deposited, and that will start growing up with one rate, that is a to the power t into y0. Now s amount he has deposited at the end of 1 year. So that will grow with the another formula, but that will again will be a to the power something only. Whatever you deposit, it will grow into a to the power t. Then next is, all will have different phase in the ledger. Okay, now can someone find out at the time t year how much he will have in the account? That we will do through the integral calculus. Okay, people can use normal algebra to have it. We will do it through integral calculus, and we will see the challenges and difference between the algebraic computation and integral calculus. Okay, is it the way I try to do to have this session? Certainly not. Okay, what we are seeing here, there is some term, everywhere term technology that is coming is a to the power t, a to the power t. Before we go with the calculus, I need to talk about a to the power t or a to the power x. What is a to the power x formula? If I say y equal to a to the power x, where x is varying, y equal to a to the power x, where x is varying. What is dy by dx? Dy by dx means if this is x-axis, if this is x-axis, this is y-axis, and this is origin. If this is x-axis, this is y-axis, and this is origin. Then what is a to the power x? A is a constant. A can be 1, then a to the power x will always be 1. If A is 1.05, the way we saw in the interest rate, then it will start growing. If A is 2, then it will start growing like this. So it will keep growing. Where if x is 10, then if A is 2 and x is 10, this will be 2 to the power 10. This is 2 to the power 5, this height is. Okay, what is dy by dx? We are talking about dy by dx. If this curve is a to the power x, if this is x-axis and this curve is a to the power x, where a can be any constant, x is varying. At this point, if I calculate dy by dx, then this is dy by dx. And what is this? Anyone will ask, what is this? This is a slope. What is slope? Dy by dx. At consider the x is any point here is 10. X is 10. Then 10 will go up and here it will hit the height, that is a to the power 10. This point is a to the power 10. At this point, take a very small region, considering that is a straight line. Possible, right? I have talked about it many times. What is the shape of moon? Ask any children. How you see your moon? Moon is called maternal uncle in India, mama. So how is your moon, mama? Maternal uncle. How is moon uncle? Then he will say it is like a football. If anyone asks children how you feel the moon is, he will say it's like football. It is where it is round. Okay, but if someone go and stand on the moon and you ask him how you feel like it, he will say it is a flat line. It is not round at all. Similar fashion, if someone is saying Earth from the moon, he will say it is a football. Okay, but can someone say that sitting on the earth, that earth is a football? Similarly, if I say, how do you feel this curve, this line is it a straight line? He will say, certainly not. This is a curve, this is not a straight line. At this point, then if I say, go near to it, go near to it, go very near to it, then how you see at a particular point, then he will say, it looks like a straight line, straight line. This is called local linearity. Means it becomes linear if you go very local to it. Take any point here where x is 10 and height is 2 to the power 10, any point here. Take a very small distance around this point, very small distance. How much small distance tends to 0? Then it will be a straight line. For that straight line, okay, if I have taken a very small section, this is the point that is x comma 2 to the power x. I have taken one point before it and one point after it, and gap between these 2 points are very small, tends to 0. Okay, if this section, if I draw a vertical line, and lower one, if I draw a vertical line, the gap in x is delta x. Similarly, at this section, I draw a horizontal line, and this point I draw a horizontal line. From this point and this point, in between point is x comma 2 to the power x. This is delta y and this is delta x. What is delta y by delta x? That is dy by dx. Understandable, right? So what is dy by dx? Dy by dx is delta y by delta x at any point x comma y. Okay, where delta x tends to 0, dy by dx. If y equal to a to the power x, what is dy by dx? How much y is changing when there is a small change in x at point x, x equal to x. If I say this point is x1, then this point is 2, this height is 2 to the power x1. If I say dy by dx, then someone would ask where? Where dy by dx? Because everywhere delta y by delta x will be different. At x equal to x1, okay, that you want. dy by dx at x equal to x1. dy by dx is not a constant term. It will come in algebra only. Okay, if it comes in algebra, what if y equal to 2 to the power x, what is dy by dx? Let's do the take logarithmic both sides. If I take logarithmic base a, then it will become log a. If I take log both sides, y equal to a to the power x, then it will become log to the power base a y equal to x. Make sense? Log base a to the power y, okay, can be rewritten as log e. E is some term. Just imagine some term e. That we need to find out now. What is the concept? First we'll deriving a to the power x. Log e a to the, I'm sorry, what is the fundamental now? Y equal to a to the power x can be rewritten as log to base a y equal to x. That will come this side. Now log base a to the base a y is written, can be written as log e y by log a e a, where e is something. What is e something? If I differentiate log of anything with base e, it will become 1 by something like that. So log base e y by log e a. Log e a will go that side. Now we have log e or ln y equal to ln a into x. If I differentiate this, then it will become 1 by y dy by dx equal to ln a. X will go away. Just ln a. Okay, so dy by dx equal to ln a into y. Y is a to the power x. So dy by dx, differentiation of a to the power x is ln or log with base e of a into a to the power x. Log base ea came extra. Now people would think, can we find what is the problem here, or what the scenario is? Scenario is, if I have a curve like this, and if I try to find differentiation of this curve at any point, curve equation is a to the power x. Differentiation at any point, that is delta y by delta x at any point, if I try to find, then one extra term is coming. I can say it as c. Y equal to a to the power x, dy by dx equal to c into a to the power x, where c is constant. I don't want c. I want a to differentiation of a to the power x as a to the power x only. Is it possible? Someone can try. Keep changing value of a. If a is 1, then 1 to the power x, what is differentiation? At any a, okay, what is differentiation? So it will come as a to the power x multiplied by ln log base e a. Okay, if the c becomes 1 somehow for any particular, if I keep increasing a, then see what is dy by dx. Y equal to a to the power x. Dy by dx at any point is a to the power x only. What I'm trying to say is, if x, consider a is 2, and x is 10. At x equal to 10, it will go here, and this point is 10 comma 2 to the power 10. This point is where x is 10 and height is 2 to the power 10. At this point, if I try to find the dy by dx, it will come as 2 to the power 10 multiplied by ln 2. Ln of 2 means ln of 2 is getting multiplied. Is it possible? This hit a person called Euler, his mind. That is it possible that if I keep changing value of a is 2, a is 3, a is 4, a is 1.5, is it possible that particular, because if we see c is a function of a. If I talk about if x is a variable, y equal to a to the power x, where a is constant and x is variable. Then differentiation come as ln a into a to the power x, where x is not in the constant area at all. So differentiation does not vary with the x, it is always a to the power x. What is varying here is with the a. With different value of a, the coefficient is becoming different. Is there any value of a for which c will be 1? It's possible when a is equal to e. Ln means log to the base e, and then e will be 1. What is e? This hits Mr. Euler brain. If I find a different value of a for the c, or ln log base e and then a, that is the coefficient I am getting with the a to the power extra thing I am getting when I am differentiating it. Can I vary a and see the value of this log base e and a? This is possible when a is e, then it will become 1. If it becomes 1, then a to the power x, where a is equal to e, then it will always be e to the power x. Means that is something that is something that can be used in mathematics. In other arena where we don't want derivative to be changed, integration will be same. If I have a equation e to the power x, and if I'm trying to calculate integration, that is the area, then it will always be e to the power x. Means whatever the height is, area will be same. Makes sense? Amazing, mind blowing, right? If x is 10 and e has some value, then at x equal to 10, this height will be e to the power x. Its integration is e to the power x only. Means that this area is whatever the height is. Can someone believe this? Can I believe, someone believe one curve like this, whose whatever the height at any point x, whatever the height is, if this if this is the height at that point, beneath it, if I see this area region, then area will be same as the height. Amazing, mind blowing. Or if I take the height here is e to the power x. The derivative will be also e to the power x only. Okay, what do you mean? You mean that if I keep growing the height, then dy by dx will also keep growing like that. Then when x is 100, then height will be very high. Then dy by dx will be that high. What is meaning of dy by dx very high? If dy by dx is very high, means it will behave like a vertical line. Vertical line means that the line slope is varying with the height. Whatever the height is, line slope is like that only. Here the height is less, line slope is less. Height is more, line slope is more vertical. If height is very high, line slope will be vertical. Or if I integrate, then whatever the height is, area will be that only. Amazing, mind blowing. This is what Mr. Euler came to him, it came to mind, because he found a to the power x equation as a very important equation. In financial area, everywhere a to the power x comes into the picture. Can someone find the value of e? It can be taken as a thought of finishing it today. Okay, we can try in this fashion. What is the formula now? Formula is y equal to a to the power x. Y equal to a to the power x. Can I break it as log base a to the power log of y with base a equal to x? Okay, then if I break it, then it y equal to a to the power x. Okay, if I do dy by dx, then dy by what we saw, dy by dx, y equal to a to the power x, dy by dx equal to ln a, natural log of a, or base e, ln a. Someone say, oh, I don't follow e. What is e is required here? I can take any base, but think e is any base one, not the Euler's a. So log base e of a multiplied by a to the power x is dy by dx. Take other way now, dx by dy equal to 1 by log of a with base e into a to the power x. Makes sense? What is dx by dy? X. What is x? If y is a to the power x, then x is log of y with base a. So d of log of y with base a by dy equal to 1 by log of a with base e into a to the power x. A to the power x can be written as y only. So more or less we have d by dx, d of log y with base a by dy, d dx by dy, d of x is log of y with base a by dy equal to 1 by c constant, that is log of a with base e into a to the power x into y. 1 by cy equal to d of log of y with base a by dy. Can someone proceed here? If someone proceed here, this is not my fundamental. It is available. So if someone proceed with this, probably he can crack the value of E. We will see more on it. Then we will see the miniature, or we can do it. Okay, if I try to do it, what is the, if I break it, how, what it will be? D of dy of something. If I say function over y, d of function over y by dy, then how I can break it? Function of y plus delta minus function y by delta, or delta y. This is the first principal rule. Dy by dx equal to y plus delta y minus y by delta y, or dfx by dx is dfx plus delta x minus fx by delta x. D of log y by dy is log y plus delta y minus log y by delta y. Make sense? Okay, minus log y by delta y equal to, that side we have 1 by cy. Okay, 1 by cy. What is log of y? Log of y plus delta y minus log of y by delta y. Make sense? If I see it closely, if I have subtraction of two items, it will go and become a division inside the log. It will become log of y plus delta y by y. Okay, by delta y equal to 1 by cy. 1 by delta y log of whatever, 1 by delta y will become exponential out there. It will become log of y plus delta y by y, and in bracket to the power 1 by delta y equal to 1 by cy. Someone can proceed here. Now it is very simple. Let's take y equal to 1. Let's y equal to 1 means x equal to 0. Y equal to a to the power x. If y is 1, then x is 0. When I have a graph of y equal to a to the power x like this, what is the value of y when x is 0? Then that is 1. It does not start with the origin, the way I was showing. It will start at 1 also. If I take y as 1, then it will become, if I take y as 1, okay, if I take y as 1, hope. If I take y as 1, I'll reassemble it. Okay, earlier we had log y plus delta y minus log y by delta y. If I take y as 1, then log y, 1 will go away, 0. Leave it. It will not be in the story itself. Log 1 plus delta y, and outside I have delta y. It will become log 1 plus delta y to the power 1 by delta y equal to 1 by cy. 1 by cy. Y is 1, so 1 went away. 1 by c. Okay, c is 1. C is 1. Okay, I believe it is easy now. Someone can try. What is c? 1 by c. What is c? C is log of a with base e. 1 by c, if I topple it, other way, invert it, it will become log of e with base a. Okay, this side I have log with base a and 1 plus delta y to the power 1 by delta y. Make sense? Log both sides with base a, they will cancel each other. More or less we have e E equal to 1 plus delta y to the power 1 by delta y, where delta y tends to 0. Okay, consider there is a value called n equal to 1 by delta y, then n tends to infinity. In that fashion, E equal to 1 plus n to the power, 1 plus 1 by n to the power n, where n tends to infinity. Now keep changing value of n 1, 2, 3, 4, 5, 6 and see after which point it will become stable. It will come as 2.78 or something like that. After which it will become, take n equal to 1, 10, 100. N tend to infinity means more stability will come after 10,000 or something like that. Okay, after 10,000, if someone is taking some value, then it will come as 2.7 something. Okay, if I take beyond that, then it will come at 2.78 something. Now 2.78 will be fixed. After some time, it too will be fixed. Point something that will be variable. After some time, 2.27. First, first indices will be fixed and next will be variable. After some time, two digit after decimal will be fixed, next will be variable. Take up to whatever you want. Grow the n. That is the e. So we have found the e. Now that is called Euler value or exponential value or whatsoever. So when we have e equal to 2.78 or so much, then it is differentiation is same as e to the power x, differentiation is e to the power x only, because c that will come prior to it, which will have log base e to the power a, log e will go away 1 only. Amazing, mind blowing. We proceed in the bank interest now. We have found something that is very interesting, how to calculate value of e. People generally they mug up in examination. Okay, E means 2.78, but how to calculate E? If someone has idea more than that, he is most welcome and he can try on his own to find the value of E. Please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number. The concept behind talking about this fundamental is we will use this log 1 plus 1 by or log 1 plus 1 by n to the power n, where n tends to infinity, heavily after this. That's why I brought this example, not to show only what is how to calculate e, because main idea is to calculate the any moment what is the y in the bank when I have deposited a y0 amount and then I have s amount every 1 year. Okay, and that is through algebraic manner, not through the calculus manner. Mean T is growing every year. T is growing every year, not every moment the way we had earlier. If someone remember, dy by dt equal to cy, that is the calculus way. Y equal to c to the power y equal to y0 e to the power ct, that is the calculus way. But right now we have pure algebraic way, and there can we use integral calculus, that we will see.